really care about. Let's go ahead and talk about what you do care about, which is those answers to the practice exam, right? All right, so that's what we're going to do today. Okay, one last announcement though before that. I may have to adjust my Tuesday office hours starting today. So I will be able to be in my office until about 4:30, but I won't be able to go to 5, and I'll try to make it up somewhere. Like I might go longer on Mondays, or I might do some extra, or I might move my office hours to Thursdays. I haven't decided yet. I have to figure that out. I've just taken on some additional responsibilities that requires me to do that. But if you need to speak to me today, I'm available until 4:30. Plus, if you really, really need to speak to me, we can meet tonight, to go over some stuff you're not sure of, like because I'm always available late at night via video chat. That's something I'm always available to do. Okay? So long as you have a webcam, a microphone, we can meet, right? It's okay. So let's go ahead now. Intro to Python, and now I did make this much longer than it needs to be, right? There was a bunch of additional practice on the back. Again. The amount of space I give you, this is very important. Just because I give you a lot of space doesn't mean it's a hard problem. The number of points indicates the difficulty and the importance. The amount of space I give you indicates the amount of space I would have appreciated had I been a student taking the test, knowing that I have terrible handwriting. Terrible, atrocious handwriting. And, I forgot to bring a pencil today, so I might need to scratch it out completely because I was using a pen, right? So I give you a lot of space, which is why these exams look long, okay? So let me just go ahead and take a look at the actual exam, right? On the actual exam, right, you'll notice over here on the actual exam that it does look long as well, but a lot of these, like as a problem a page, right? This is an entire problem, this is an entire problem, this is an entire problem where you have plenty of scratch space. What? Oh. Sorry. Oh, this is because I had to borrow this because I don't know where my adapter is. So apparently I have to mirror them. Oh, this is going to look terrible. Come on. Ugh. Okay. Whatever. That's going to look terrible, but whatever. Or no, I'm going to cheat. Sorry. You see, nice thing about this is that you eventually learn about being, working with technology is eventually you get to learn how to do wizard things like this. Hey, there we go. All right, so that way at least I don't have to change the weird settings here. Okay, so useful notes. You can clarify any answer you give, right? You can ask for clarification from your TA. If you're interpreting a problem in a certain way and you're not sure that I might understand that, write that down on your exam. All questions are essay questions, by the way, even the ones that are multiple choice. So, in other words, if you write it on the exam, we will look at it and take it into account. Students have successfully argued things or put things down that have resulted in them getting extra credit or turning a wrong answer into a right answer. You'd be surprised how that works. And don't leave questions blank. I can't give partial credits to blank answers. The way partial credit works is that generally if the answer looks to be in the right direction, I look for minor things that you might have done to deduct points, such as, you used the wrong variable name here, but otherwise it's right. You forgot a colon. Stuff like that depending on that might take off a point or parts of a point. Right? If it's mostly wrong, I look for the things that were vaguely in the right direction so I could give you a couple points credit. Okay. And then also I list these things over here which I think are kind of useful. Okay. And the more we get into the semester, the more will be listed there. Okay. So back to this exam over here. All right. One. So these are from the first lecture. Computer science is the study of computers. No, that's false. Computer science is not the study of computers. What is the not wrong answer to that? Yes? Yep, computer science is the study of algorithms. That is the not wrong answer. There's other more complicated definitions, but if you say it's the study of algorithms, then then basically most computer scientists will say, yeah, I guess it is. All right, Alan Turing is often considered to be the first programmer. True or false? False. Who is often considered to be the first programmer? Ada Lovelace. Yes. She is often considered to be the first programmer because she did actually write a program for a computational machine that never even got built. But there were designs for it, and that was enough to write a program for it. Oh, and that answered that question. Why is she an important figure, right? So, now there will be an entire, the first page will be similar to this. Don't spend too much time on it because it's not worth that many points, but it's there for you to just buffer up your grade. On the actual exam, we're going to have these questions here, 10 basic questions. Every semester I consider removing them, and every semester I'm proven wrong that I shouldn't remove them because there's somebody gets like almost all of them wrong because they haven't been paying attention. All right, remember, order of Python. So you are going to evaluate these, and you're going to use order of operation rules that Python follows. All right, so what do each of these expressions evaluate to in Python? You will not need a calculator for any of these, okay? Numbers that get bit, right, if you're multiplying by big numbers, then it will probably be 100, or if it's got a number that isn't 100, it's a trick question, okay? So 2 times 3, so we've got 2 times 3 divided by 6 times 100. We do, since those are all operations, we do them left to right. So 2 to 3, 2 times 3 is 6 divided by 6. That's integer division. That gives me what? 6 divided by 6 is 1 times 100 is 100, right? All right, 1 mod 2 plus 3 mod 2. Now, modulo is a division operation. So times, multiplication, division, and modulo all are on the same tier. So 1 plus 2, 1 mod 2 is what? What's the remainder of 1 after it's divided by, what's the remainder of 1 after it's divided by 2? 1. What's the remainder of 3 after it's divided by 2? 1. So 1 plus 1 is 2. All right, not a trick question over here. -1 plus -10.5. So -11.5. Just remembering if you can do negative numbers, right? Remember, negative numbers are a thing, and that that your computer can handle them. It's not error. Again, this question D. Do you remember order of operations? 3 times 2 is 6. So it's 4 plus 5, which is 9, minus 6, which is 3, right? 4 plus 5 minus 6. All right, 0 times something ugly is what? 0. 0 times something ugly is 0. Minus 1 is -1.0 because we have a float in there. Make sense to everybody? So again, ugly numbers equals, it's probably that, if you're adding together ugly numbers, it probably doesn't matter. One other thing I like to do is multiply something against some ugly number, except that thing ends up being 1, so it's not hard to multiply it. Or 0, so it's not hard to multiply it. 2 times 4 minus 20, again, just checking, do you remember order of operations? 8 minus 20 is -12. All right, here, 7 divide 3 is 2, right? 2 plus, not 2, but 2 times 3. So 2 plus 6 is 8. Remember, order of operations. 4 mod 2 times 3. What is the remainder after 4 is divided by 2? 0. So 0 times whatever is 0. Big number, divide, an even bigger number. 0. This big number goes into that exactly 0 times. So the answer is 0. All right, and this last one I completely threw at you out of nowhere. It's actually just a way to teach you that, and get your attention that, hey, Python and other programming languages all handle scientific notation, right? So if I do 10e to the first power, that's 10 times 10 to the first power. Or if I do 2 times e to the first power, that's 20, right? E being 10 to the what power? 10 to the 10th power would be that many zeros behind it. 10 to the second power, 200, right? So it's just that scientific notation. This is the first and the last time you will see it in my class. It's just simply there. So this would be 10 times 10, which is 100.0. All right. So now we have Boolean expressions. On the exam, there will be 5 of these. And they will drive you insane. So, all right. So true or 3 equals 2. Is 3 equal to 2? No, that's false. So the statement reduces to true or false, which reduces to true, right? So this becomes true, right? A nice thing about expressions is that if you're unsure as to what they evaluate to, as I'm sure many of you find out, you can just throw them into your computer, and it will spit out the answer for you. What is not false? A lot of things are not false, but specifically on this exam, true. So if you accidentally write false with a lowercase f, because that's the way it works in a lot of other programming languages, then we are going to end your computer science career right here and right now. No, I'm kidding. It is completely ununderstandable, and in fact, if you want to take a shortcut and just put T or F here, then that's fine. Just make sure I can tell it's a T or an F, right? All right. So the not goes in front of a thing like this. So 4 is less than 2. So that is false. 4 is not less than 2. So not false is true. So it becomes true on the left side and true on the right side. So this becomes true. Oh, I remember changing this one because it was a pain in the butt. All right, so this one is actually to teach you to reinforce a rule, right? Because this one I just want to make sure tells you it's true, right? Which is intuitively correct, right? 32 divided by 8 gives me 4, and 32.0 divided by 8 gives me what? That gives me 4.0, right? So 32 divided by 8 gives me 4. This side gives me 4.0. So I've got 4 on one side and 4.0 on the other side. So are those things equal? Well, Python doesn't really care when it comes to, it can't really compare the integers to doubles or to floating points. So what it does is that it converts the integer to a floating point. Okay? So it's 4.0 equal to 4.0. And that's why it's true. Right? Of course, if you're like, yeah, that would make sense that 4.0 is equal to 4, then also true because Python is supposed to be unsurprising like that. But remember, the reason I put this on here is just to remind you, anytime you do any kind of operation where you've got on one side an integer and another side a float, you convert that integer to a float. Okay? And this one's just there to mess with you. Okay, so because I do like to make things harder on the practice exam, right? In general, when you see these kind of things, and some professor like me is trying to mess with you, what you want to do is take it and start scratching out bits, right? And work from the inside parentheses to the outside parentheses. All right, true or expression. I don't care what this is, actually. I don't care what this is. True or anything, right? True or anything reduces to what? True. Right? Let me go ahead and remove those parentheses, right? And you can just scratch that. True and not, okay, false or true, again, right? True, that reduces to true. Okay? So not true becomes false. Okay, true and false becomes false, and not true becomes true, and if you write anything like this in real life, something's gone horribly, horribly wrong. Right? All right, so for these are a bit more abstract, right? If you wrote I was just asking, this one's fairly straightforward, though. If you write if statement that checks if x is a multiple of y. So this one was a bit tricky because it involved math for some that, and there's some aversion to that. For instance, how would I tell if a number is a multiple of 5? How would I tell if 100 is a multiple of 5? Yes. I could do modulo, right? I know that something is 100 is a multiple. I know that like 100 is a multiple of 5 because it's divisible by 5. If I divide it by 5, there's not going to be any fractional pieces of it, right? So the way I figure that out is I would say mod 5 equals 0, right? So to do any number, to check if any number is a multiple of another number, I would say if x mod y equals 0. Okay. All right, this one's one that I've really liked for practice exams for the longest time. And the way this practice exam started out was that it used to be an exam, and then I just took it and made it a practice exam and made a new exam that was based off of this one. So this used to be an exam question, and I'm like, looks like a nice one. So write an if statement that checks if either x or y is even and the other one is odd. Okay? So in other words, if x is even, then y has to be odd. But if y is even, then x is the one that has to be odd. Make sense? Okay, so how do I know if x is even? Well, I check if it's divisible by 2. Okay, and since it's an and statement, it needs, and because another thing has to be true, well, if x is even, then y has to be odd. I need an and statement. So if x mod 2 equals 0 and I'm going to go ahead and save this so we get syntax highlighting. Go into classroom. Sorry, 1 second. Classroom. And then we're going to put this into ITP, and we're going to call this, we're going to overwrite this from yesterday, replace it, boom. So if x is equals 0 and y mod 2 equals, well, we could do either 1 or we could do not equal to 0. Again, not equal is, this. But if you do a not equal sign in class, I'm not going to really care anymore, right? Same with less than or equal to. If you want to just simply, because, you'll translate that in actual code. If it's on paper, you can take some liberties. Okay, if x is equal to 0 and y is not divisible by 2, so if x is divisible by 2 but y is not, or, and I don't remember the order of operations for and or, and I never taught you, like, do ands take precedence or ors take precedence? I don't know. And frankly, when you're coding 4 years later, you're going to be like, wait, which one should I use? Yes?
It's neither of them. It's just whatever comes first.
It's whatever comes first? Some languages, I think it might matter. I don't know. But you know how you get around that? Parentheses. So I like to put stuff in parentheses if I'm not sure. Parentheses are your friend, and they also make sure that when you come back and reread it a decade later, you don't have to reteach yourself that rule you just taught yourself. And thank you, by the way. So if x mod 2 is odd and y mod 2 is even, right, is equal to 0 there. And I'll just put pass over here. And pass is a magical word that basically means do nothing, but I'm leaving this blank for right now in Python. It's a magic word, right? If I left this the way it was, it would throw a syntax error. And pass simply says, yes, I left it blank. I left it blank because I just wanted to write the if statement.
How's that different from a comment?
It actually, it sees it. It sees it. If I had a comment there, it would still throw an error. Like here, if I just leave it blank, it's going to say syntax error. You got to end a file while parsing. Same over here. It's going to say, hey, there's an error. If I do pass, it's going to say, congratulations, you wrote a program that does nothing. Oh, x is not defined too, so but that's fine. Yes. Yeah. Yeah. if it falls within the spirit of the answer, then it's fine. Yes.
Wait, so when I did this, I did a program that checked if X was even or odd, and then it checked if X was even or odd, and then it said X is even and Y or odd. Is that incorrect for that?
No.
Oh, okay.
You could, so long as it checks if one is the other, and it uses an if statement.
I just modded by 2 for X and Y.
Mm-hmm. You could sum them, yeah. So, rule of addition, if you add two evens together, you get an even. If you add two odds together, you get an even. And if you add an even and an odd together, you get an odd number. All right, so what's the output of this code? So we've got a for loop with a if statement in it, right? So for I in range 0 to 9, 0 through 9, right? So it's up to 10, but not including 10. If I mod 3 is 1, so if we divide by 3 and have 1 as a remainder, then print out the number. So let's go through the numbers. Is 0 divisible by 3? No. Well, 0 have a remainder of 1, rather, when divided by 3? No. Does 1 have a remainder of 1 when divided by 3? Yes, it does. So we'll print out 1, and we'll just put it over here, and we'll not put the next number on a new line. So 2 has a remainder 2 when divided by 3. 3 has a remainder 0 when divided by 3. 4 has a remainder of 1 when divided by 3, so that goes down over here. So we've got 1, 4 now, right? 5 has a remainder 2. 6 has a remainder 0. 7 has remainder 1. 8, so we put down 7 as well. Then 8 has remainder 2. 9 has remainder 0. And then we don't do 10 because we go up 2, but we don't include 10, right? And of course, because I, went through the effort to make it so, you can pretty much copy and paste that into a file and check for yourself, right? Right? It's the nice thing about code. You can check all of your answers for yourself. 147, right? It's not, yes? Right. So when we do 1 divided by 3, right? In terms of like long division, right? We get how many times does 3 go into 1? 0 times. So we can't divide by it anymore. So the quotient is 0 and the remainder is 1, right? So that's why. Generally, in the easy way to figure out mod, if you've got x mod y, where x is less than y, right? And this just puts it in really abstract terms, and that gives you x, right? So if you've got 70 mod 100, the answer is 70. If you've got 12 mod a bajillion, then the answer is 12. Similarly, like if you've got a big number mod 2, it's just going to give you 1 or 0, depending on whether it's even or odd. Okay. Convert the following while loop into a for loop, right? So in other words, let's figure out what the while loop, so in order to do that, what we've got to do is figure out what the while loop does, and then we just want to write a for loop that does the same thing. That's all I mean. Okay? So I is equal to 2, while I is greater than 0, we print out an exclamation point. So 2 is greater than 0, so we'll print out an exclamation point. Then so I'll go ahead and take this over here, right? So we can, because you should never really try to figure out these things in your head, even though I'm totally doing that right now. But then again, I wrote the exam, so, So I starts at 2. I is 2. And then I'll put my output right over here. So output. So while I is greater than 2, I is 2, so it's greater than 2. So we'll print out an exclamation point. Okay? And then I minus equals 1. That means we should decrement I by 1. Okay? While I is greater than 0, 1 is greater than 0, so print out an exclamation point and decrement by 1. 0 is not greater than 0, so we're done with the while loop. So it just simply prints out, well, not 2 exclamation points, but, an exclamation point on 2 different lines, right? Okay, so we just need a for loop that prints out, that prints out 2 exclamation points. So for I in range 2, this does essentially the same thing. If you go backwards, that's perfectly fine as well. The more I care about the functionality of your answer, instead of saying, oh, you didn't go backwards, so therefore it's wrong. Right? No, I'm just care. And that does the same thing. It prints out 2 exclamation points.
But does it print out different lines?
It does, right? Because as long as you have a print statement, and it's just not got anything attached to it, it's going to put out its output will be on different lines. Right? If you have an end on it, if you have the end empty string, then it's just going to glue everything the next output together. This is going to put the next output on a different line. Okay. What is wrong with the following loop? It's infinite. It will run forever. While I is 0. While 0 is less than 10, print out 0. It will print out 0 forever. You could argue technically there is nothing wrong with it because it doesn't crash. You could technically write that. And I suppose, and if that's what the developer intended, then that's what the developer intended. It's a feature, not a bug. But it's a loop. How could I fix this, by the way? Yes? Yeah, I could do plus equals 1, I plus equals 1, like below here, right? Or I could do I is equal to I plus 1, any number of ways, just so long as I increment i's value so that this eventually becomes false. All right, so this one I know is driving some people crazy. You'll be relieved to know that this is one of those where I'm just simply building up your muscles, and I don't really expect to have that on the exam. Okay? These are ones that are building up the muscles, right? So, in fact, this is the closest thing that you'll get to what's on the actual exam, this one over here. But you'll get a much easier version of that. So, So, okay, write a nested for loop that prints out the following. 10, 8, 6, 4, 2, right? So, again, this one also kind of requires us to be able and because you're doing it on paper, you got to be able to figure out what's going to be the output of some, we've got to be able to create some code that's going to do this without us actually ever being able to test it on a computer. So the first thing I want to be able to do is print out, well, let's go ahead and just say print out 10842 either this way or 10842 this way. I'll say let's do it this way, 10842, right? Just that first line. So let's go ahead, for num in range. So I want to start from 10. I want to go down to, I want to stop at 0, and we're going to go down by 2s, right? And then if I did print num, if I get print num, and then if I do, I have 2 options here. I can do either end is equal to blank blank, and then do print, this is the not fun way to do it, which says print out the number, print out a space, and glue it together. Or I could take advantage of I know how end works, which is that I can just put a space and say end that print statement with a space. So if I run this, it'll do num will be 10, so we'll print it out. Then it will be 8, then it'll be 6, and then 4, and then 2. I have no idea when I count that. I have no idea why that when I count by 2s, I skip 6. It's probably because I'm so used to going up by powers of 2. All right. But we have a bit of an issue here. So first off, I do know that I need 5 lines here, right? So for line in range 10, range 5. And there's a ton of ways to solve this one. So, and I'll be putting up a couple of different options. For range in 5. So if I do this now, I've got a nested for loop. And it will print out the following. It will just print out the 10, 8, 4, 2 5 times. And it won't be on different lines because I didn't put in anything to say they should be on different lines. So for line in this, we'll print out the line. And then I will do a print statement over here to advance the new line. Right? If I just simply do print empty string, it will print out a new line. Or if I just do print this with nothing, it'll go to the next line. Okay? But now I'll get 10, 8, 4, 2, 10, 8, 4, sorry, 10, 8, 6, 4, 2, 10, 8, 6, 4, 2, 10, 8, 6, 4, 2. All right? So what I want to do is that, what really changes? The pattern doesn't change at all. Right? I'm always subtracting from 2. What I really need to change is what number I'm starting from. Right? So I'm going to instead turn this into a variable to make this a bit easier and figure out what my start should be. Right? So I need to say start is equal to what? So I'm going to do this 5 times. So there's a couple ways I can do this. I can create a formula like this and say, well, I'd like to start from 10, and then I want to subtract 2. Then I'm going to do 8, then 6, then 4, then 2. That's what I'm going to be starting with. So 10 minus, let's see, line would give me 10, 9, 8, 7, 6, right? Because line is going to be 0, 1, 2, 3, 4. But if I multiply by 2, it's going to give me what I want. So it will be 10, 8, 6, 4, 2. That's great. So start will be what I want each time. So that's one way to do it. Okay? Another way to do that is that I will turn, that's one way to do that. Another way to do that is to turn this into start, right? But then I'm just going to get 5. And if I do that, right now my code will do 5, 3, and that's not going to work out too well, right? 5, 3, 1, that's not what I want. And then it will be 5, 4, well, so we obviously need to start, we need 10, but now I'm getting 10 lines, right? So I'd get 10, 8, 4, 6, 2, then I'd get 9, 5, and then I'd get 9, 7, 5. So obviously this one should go down by 2s as well. And it turns out, just by happy coincidence, that by doing this on the outside loop, right, the starting number should be 10, then it should be 8, then it should be 6, then 4, then 2, that this solves the problem as well. So there's a lot of ways to do these different ones. There's a lot of different ways to do these ones. And these ones are all about building up muscles, right? We're going to get more acclimated with for loops when we actually see them in a non-theoretical, non-BS application, such as when we're slicing strings apart, which is about as fun as it sounds. Anything with that slicing is fun. Okay? So let's take a look at this one. Note that most of these were like 4 points, and this one was like 6 points, so that's also just kind of a subtle indicator that, hey, I want you to pay attention to this, right? But subtle, okay? So, for I in range, so what's the output for this? So again, the way we need to work this is we need to basically want to write what's going on. We need to turn our head into the compiler, essentially, into the Python interpreter, okay? Which is really hard to do to begin with. But it's something you should be able to, it's a skill to learn, at least for small blocks of code like this, right? So I is equal to, so let's go ahead. For I in range 3, that means I is going to be the values, I is going to be over the range, I is going to be over the range 0, 1, 2. Okay? And I is going to start out at 2. Sorry, at 0. So for j in range I plus 1, what is i's value? 0. So the range is going to be from 0 up to, but not including 1. It's going to be, so it's going to go up to 0. So j is going to start out at 0. Great. Okay. So now we're inside this for loop. So print I plus j. What is I plus j? 0 plus 0, right? Not a trick question there. Output 0. Okay. So now we're done with this print statement. Let's go see. Does j have any more values to b? Nope. We've gone over j's range. So we're done with j. Right? J's done with. So now we go to the print statement. We print out a new line. Okay? And then we are done with this first run of the for loop. So we're done with I being 0. Does I have any more values? Yes. I needs to be 1 now. Right? We still have more numbers in the range for I. So I's range is 1. For j in range 1 plus 1. So range 2. So range 2. So I's values are going to be 0 and 1. Sorry, j's value is going to be 0 and 1. J is equal to 0. Okay. So what is I plus j right now? Because that's what we need to print out. 0, it's 1 plus 0, so it's 1. Okay. So no space, and it says don't put a space there. Great. So we're done with that, with j being 0. Does j have more values to b? Yes. 1. J should be 1. Okay. So what's 1 plus 1? It's 2. Put down 2. Does j have any more values to b? Nope. So continue on. So we're done with that. Print out our next line. We do a print statement, and I is done being 1. Does I have any more values to b? Yes, 2. So I is now 2. So now j in range 2 plus 1, so 3. So j's values are going to be 1, 2, 3. Sorry, 0, 1, 2. Okay, so so now let's print out. What is I plus j? Okay, so we're done with j being 0. What is I plus j? 3. And we're done with j being 1. And what is I plus j? Okay, we're done with j being 2. J has no more numbers to b, so we're done with it. And then we do a print line statement, which if you somehow forget to draw an empty line, don't worry about it. And then we're done with I, because I has no more values to b. So our output is 0, 1, 2, 2, 3, 4.
I'm still trying to figure out the 4 j range, like I plus 1. Like up there the range 0, 1, 2, I get that, but then why isn't it like 1, 2, and 3 since I plus 1?
I plus 1, because I plus 1 gets translated to 0 I plus 1. Right? If there's only one number, we always start from 0. I'm going to keep going on so that we can get to all of our questions. Okay. So if you can't tell by this page, then I have some questions that are just there to annoy you. All right, so what are the values of x, y, and z after the following statements? I'm trying to remind you that the equal sign is actually the assignment operator, and therefore works a bit differently than you would expect. So what is x, y, z after the following statements? Again, don't try to solve this in your head. You gotta actually use your pencil and write them down. Okay, So we've got x is 7, y is 5. So I'll put them in comments over here. X is 7, yep. X is 7, thank you. Y is 8, and then z is -5. All right, so now let's go ahead and see how did I decide to mess with you guys. So x is equal to x plus 1. So what we're going to store in x, 7 plus 1. So we're going to store 8 in x. Y is going to be 8 plus 8 plus -5. So 8 plus 8 minus 3. So that's 16 minus 5. I feel like King Arthur here. All right, so 8 plus 8 minus 5, which will give me 11. So we're going to store 11 in there. And then z plus equals 1. So we're going to increment -5 by 1, which is going to bring it up to -4. Okay. So there's a couple of things going on there that I'm checking that this question actually checks. First is basically, do you understand how this works? And the next is a consistent model of modifying variables. That is to say that basically this is an assignment statement. This isn't a binding equality operator. So when we suddenly do z plus equals 1, it doesn't change the value of y. It doesn't go back in time and rewind what you just did, which is actually a problem that you sometimes get with some students, like in the first couple days. All right, so what is the output of annoy? It's apparently nothing because I decided to forget to change that from, this is how you do or in other programming languages. So I apparently forgot to change that. Okay, so just everybody pretend I didn't mess up there. All right, 2, 3, 4, 5. Okay, so is 2 is greater than 3. That's false, so we don't even have to bother checking the rest of this statement. Is, oh, what does, oh, I forgot. Yeah, 5, 4, 3, 4, 2. All right, so is 5 greater than 3? Yes, it is. Is 5 less than 4? Less than or equal to 4? No, it's not. So we immediately can discard the first block. Is 2 greater than 4? No, it is not. And is 2 less than 3? Yes, it is. So that's an or statement, so that's true. So we print out green. All right, 2, 3, 4, 5. 2 is not greater than 3, so this entire thing is false. We don't have to bother checking the rest because we've got an and statement there. In fact, your computer's going to just if as soon as it like sees an and statement and it sees that one side is false, it's not even going to bother looking at the rest of it. It's going to do what's called short circuiting and say, I don't have to check the rest. I already know the answer. Okay. Next, is 2 greater than 4? Sorry, no. Sorry, is 5 greater than 4? Yes, it is. So this is true. So it's also green. All right. I like this one. This used to be a test question as well. Def foo, def bar, def baz. All right. So we define foo, bar, and baz. Foo prints foo, bar calls foo, prints bar, calls baz, and baz prints baz and calls foo. Deliberately annoying. Okay, and then we do foo, bar, and baz. So the question is, what is the output? All right, so we call foo first, so we're going to get foo. Whoops. Let me go ahead and let me go ahead and steal this copy. Yeah, that did not go as intended. Okay, so we've got foo, bar, and baz. So what's the output going to be? So we've got foo, So its output is going, and I'm just going to go ahead and put it on one line so that it will fit. But obviously they'll be on different lines for the real answer. So foo's going to call print foo. So we do print foo. Bar will call foo again. So we'll print out foo because foo prints out foo. Then it says, bar says to print out bar. And then bar calls baz. What does say baz say to do? It says to print out baz and call foo, which prints out foo again. And then we call them, so we're done with calling bar. So then we call baz, which says to print baz, and call foo again. So our answer should be foo, foo, bar, baz, foo, baz, foo.
One more time.
What?
Seriously, one more time.
Foo, foo, bar, baz, foo, baz, foo. Okay. I like this question, though, because what happens if we put a... The question is, what happens if we put a bar right over here? That is the second question. Yes? It'll just keep going. I think actually what will happen is I get a Stack Overflow exception, a recursion error, but I wouldn't expect you to know that. That's basically saying you have functions calling functions and it never ends. And I'm trying to store all the function calls in memory, and I can't anymore. Right? You'll see that it's just gone too long. But yes, essentially, it will. In theory, it would never end. So yeah, it's infinite or generates an error are both correct answers there.
So what's the right answer for this problem?
The answer that I would accept on an exam is that it's infinite, or that it causes an error. I accept either of those. Right? I would.
I did like the first 12 lines, like, it matches that. So that's the answer I want.
Well, the thing is that it goes on forever is kind of the idea. All right. So this one, Confundus, is one of those ones where I am really being a jerk for good reason. And this one, a variation of this always appears. I include this one because we used this in 1068 to point out that a variation of this question always occurs on the first exam, always occurs on the second exam, and always occurs in 1068's common final exam, at least when common final was when 1068 was the intro class, because we wanted to make sure that you understood the difference between names, right? And there is no way for me to solve this one just simply in my head. I don't. It's stupid. Don't do that. Okay? Okay, so here we've got Confundus, which says x is 6, y is 8, and z is 4. Okay, but then notice over here I've got zxy. Okay, that means that it's going to be passed in as 4, 6, and 8. Okay? Now Confundus takes in a yxz because it can. And because this is the question where I get to be a jerk. And so I take great pleasure in doing so. However, the names don't matter. What matters with the variables is the order of your variables. So y is 4, 6 is x, and 8 is z. Everybody following so far? Right? 6, 8, 4, x is 6, y is 8, z is 4. We pass in 4.
You wrote it different up
Yeah. I did. That's the point. 6, 8, 4, 4, 6, 8. Z is, so we pass it in the order it appears, right? So we pass in 4, 6, 8, so we get y is 4, 6 is x, and z and 8 is z, or z is 8. Because what matters is the order, not the names. If that confuses you, just remember I could easily do a, b, c over here. And you could just simply replace all the y's in this function with a's, all the x's with b's, and all the z's with c's. Yes?
So effectively, the lessons up that don't matter.
Yeah. The letters, yeah. Yeah, so in the function, the x over here is different from the x over here. You know, that's why I can have so many functions that like have, you know, that take in the same variable name. That's the reason. Because once you create a variable name in a function, it assumes that's the variable name that exists for this function. Okay? So it's also a good reason why you shouldn't name things just x, y, and z sometimes. Anyway, so we've got 4, 6, and 8. So let's go ahead and increment x by 1. So this becomes 7. Then y has to be y minus x plus z. So 4 minus 7 plus 8. I'm just going to do this in the way that makes sense for me, which is that, so y minus 7 is negative 3, right? Right? Y minus 7, that's 4 minus 7 is negative 3. Then plus 8 would be 5, right? So we're going to store that in here. And then we print out zyx, which would be zxy, which would be 8, 7, 5. Whoops, right? So we've still got this foobar vase thing going on. So let me comment that out, run it. 8, 7, 5. So there will be a question a lot like this on the exam. Okay. All right. So, yeah, we're not going to do anything super cruel like, you know, where basically, yeah, and then, we do all this work, but then it asks you to print out the return of this, and it doesn't return anything, so. All right, for each function, I like to put the example inputs and outputs just simply so that we have clarity. Each character returns a new string separated by each character with a comma and a space. All right, so let's go ahead and do that. So hello gives us H, comma, E, comma, L, comma, L, comma, O. So this one's actually a bit of a tougher problem than I'd actually put on the exam because we haven't gotten too comfortable with string splicing yet. So if you were able to get something close, and I need to call this W, you know, each character word as opposed to str, because str is a protected character, protected string actually, right? So output is equal to empty string, and then we're going to return output. Okay. So if we do 4-letter in Word and do the following, if we do output is equal to letter plus comma space each car, we actually get something that's close to the answer, and you get most of the credit. A good deal of the credit, at least on this one. Word, hello. Oh, right. Print. Oh, what did I do wrong? Letter, output plus letter plus. There we go. So take the output, add letter to the current letter to it, and add comma space to it. And we get H-E-L-L-O, but we have something, but we're differing by the answer in a significant way. What's the significant way that we were differing from the example input and output? Yes? When we have the finer letter, we have a comma. Oh, that's annoying. All right. So on the actual exam, if you remember, I have like these things over here at the beginning of the exam to tell us some help. So perhaps if we're flummoxed, we can look here for some guidance. Right, we can do string slicing. We can tell how big the length of the string is, and we can also get an individual character out of a string. Okay, that's everything I need. So what I'm going to do is, rather than going and printing out every letter in the string, I am going to go ahead and print out everything. But the way to solve this is that, well, I need to print out a comma and a space after every letter but the last. So I'm just going to run this loop over every letter but the last. So we're going to start at the first index, right? And we'll learn more about this on Thursday after your exam. So this should give you a good indication that this isn't necessary. This part of it isn't a necessary skill for your exam. 4-letter in Word, and then let's see, go up to the length of the word. Well, if I did -1, -1 brings me to the last index, but it would stop before it, so that should work. Hell. And then all we need to do is do output over here. So we've got everything. Output is equal to output plus the last letter So that's how we get that one. Now, another way to do that is to change it to this. Range length of word, right? -1. For I in range length of word -1, and then do word I. But again, what I care about is basically more of the, can you go through every single letter? And then, what was the issue there? Oh, length. Right, but again, this is something I just didn't bother changing from last semester, where I had where we got further just simply because I was working in a group of 8 students, which means that if you don't understand something, I can spend a lot of time with you individually. Right? Small classes are great. All right. So this one is but more of the point was getting, could you do H comma E space, E comma space, L comma space, L comma space, O comma space. If you were able to get there, you'll be fine on the exam. You'll be probably fine on the exam. Okay. Next, sum of 3's, which returns the sum of the first n positive integers that are divisible by 3. Oh, and again, you can see that it's the artifacts of Java code over there, because those are Java comments. All right. So here we're doing basically, if n is equal to 3, it'll be 3 plus 6 plus 9, because those are the first 3 numbers that are multiples of 3. If we do 5, we want the first 5 numbers that are multiple of 3. 3 plus 6 plus 9 plus 12 plus 15. And if we don't get a valid number, then we just return 0. So let's do that check first. If n is less than or equal to, less than, equal to 0, right, and this is described in the problem prompt, then we want to return 0, right? If it's not a valid one, then we return 0. We don't need an else here, but I'm just going to do it anyway. Else, I will create a variable called total, and I'll start off at equals 0, because I'm going to do a running sum. When I have to add a bunch of things together and those things change, I want a running sum. So return total. Okay, so now how many, if I get 3, I need to add 3 plus 6 plus 9, which is 3 numbers. If I get 5, I need to add 3 plus 6 plus 9 plus 12 plus 15, which is 5 numbers. So whatever number I get is the number of numbers I'm going to have to add. Right? So for num in range, and again, there's a lot of different ways to solve this one, n. So I'll have to add 5 numbers together. So let's see. If I were just simply to do total plus equals num, that would be 0 plus 1 plus 2. Like, let's go ahead and just assume n is 3, right? If n is 3, then this would be 0 plus 1 plus 2, because n's range would be 0, 1, 2. Totally not what I want. I want 3, 6, 9. Right. What about if I multiply number by 3? Before I add it. 3 times number. Assuming I can, type. 3 times 0 is 0, so no luck there. What about over here? 3 times 1 is 3. 3 times 2 is 6. So that turns that into 3, 6. Now, it turns into 3, 0, 3, 6. Which is close, but close. Yes?
Do you do like parentheses, like root times 1 plus 1?
Yes. Although you did ruin my joke about nuclear weapons, so I'm just giving you a hard time. Don't worry about it. So if I do that, then it will be so 3 plus 6 plus 9, right? This will increase this so that number will be 1, then 2, and then 3. So it'll be 3, 6, and 9, and that will work. There are a lot of ways to solve this problem. The other common way I've seen to solve this problem, so another common way is to just do 1 to n plus 1, so that we don't have to do that number over there. Or some people like to do all their control entirely in their for loop. So they'll do, we'll start with 3 and go up to n times 3. Because they're like, oh, well, 3 goes up to 9, which is 3 times 3. 5 goes up to 15, which is 3 times 3. And then we'll go up by 3s, because that's how often we go up. Oh, but I need to add 1 to it because I need to include that last number. So that's another way to do that. All are equally valid. If it works, on the exam we take the philosophy of it works, it works. Yeah, if it works, it works. Right? You're allowed to use stuff that I have not taught in the class on an exam. In fact, I give extra credit if you manage to teach me something. For instance, some students in Java, by the time they get the data structures, have done enough that they can start doing stuff like anonymous functions and lambda expressions, and I didn't know you could do those in Java. Or they start introducing new things that I just don't know, and I have to look it up. Like I found out, oh, is that really a method call? That can't really be a method call. It is a method call. Whoa, that's built into the system? Darn, that makes this problem easy. Happens multiple times. And well, you know what I do? I give you full credit because I don't like penalizing students for knowing too much. All right, write a program that uses a turtle to draw a spiral. All right. So to draw a spiral, basically, what we have to do is that we have to draw some shape, right? So I'm going to go ahead and just I'm going to create a new file here. So new save, and we're going to save it under classroom, intro to Python, turtle review. All right, so we need a program we need to write a turtle program that draws a spiral. So the first thing we need in a turtle program is import turtle. Don't forget it. It's not like going to be the end of the world, but it's an easy way to lose a point, So just, don't lose a point. Take the free point of remembering to write import turtle. Yeah. So Next thing to do is that we don't really need I need to do this because I'm not working in idle and I'm working on an IDE. Turtle.done, so that when I do the turtle program, the window actually stays up. You don't have to care about your window staying up on your program. So if you forget turtle.done, if you put turtle.done, great. If you don't put it, oh well, it's not going to count against you, right? But you just got to remember to do import turtle. Okay, so to draw a spiral, we need to draw some shape. We got to draw some polygon. But each side of the polygon needs to go, a bit further than each other side. So, for instance, to draw a triangular spiral, I need 3 sides. Right? So to draw a triangle, for instance, I would like to, for blank, I can use blank when I don't care what the variable is. Actually, I will be counting what it is, so I'll call it offset. Offset in range 3, right, print, sorry, not print. Oh, and I need to create a turtle, right? Bob is equal to, and again, you can name your turtle whatever you want. I use Bob because it's 3 letters. Turtle to create my turtle. If you say, if you somehow don't write it on your sheet and forget how to create your turtle, but you're supposed to create one, just mention that, like, put something like Bob is equal to make new turtle here. We'll give you plenty of partial credit for that line. Don't worry. So we care about the algorithm. And knowing the algorithm, the steps you're supposed to do, even if you forget what the exact step is, counts for a lot. Okay. So then we need turtle to draw a triangle. We would do turtle dot forward, which we can write as forward or FD because your hands is probably hurting at this point. So move forward 50 steps, and then we basically want to divide it into 3 turns. So 3 turns that would add up to 360 degrees. So it would be Bob.fd and Bob.left or LT 120. Right, and this would draw a triangle. Great. But what makes it a spiral, which is the original question, is that I need to actually go a bit further each time. So if I do offset plus, so same angle, but offset plus, offset times 10, right? So each term we increase it a bit more. Now that doesn't really look like a spiral because we only went 3 sides, right? We only did 3 turns. So let's go ahead and increase this to like 30 or something, right? Shoop, 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 shoop. There we go. That makes a spiral, right? Gives us a 10-layer spiral because, there's 30 turns. All right, and that gives us a triangular spiral. Didn't specify what shape I wanted to do it. How would I make a square spiral? What would I need to change? Yep, change the angle to 90. Do I need to change the distance it moves at all? Nope. Right, and there we go. And there Bob happily just draws his spiral.
How do you do a circle?
How would I do a circle? A circular spiral? Painfully. Probably using the circle command. I would probably say you'd have to use the circle command to do so. I would guess maybe like saying a circle and then offset plus, and then you would say like, let's say 90 degrees of it. Let's see if that works. Something like that, but not really. All right. Let's see. If I do, instead of turning, if I just don't turn, let's see what happens. There we go. If I don't turn instead. Yep. Right, because I forget with the circle command, the circle actually, turns. So, excellent question. So, how would I draw out like a pentagular one, a pentagular spiral, one that looks like a pentagon. I would need to divide 360 by 5, which gives me, I have no idea. I don't know what the math is. That's what I have what? 72? That sounds about right. Okay, so 72. I don't know. I can't do math. That's what the computer's for. Oh, I have to get rid of the 90 over here. Right? And there's a pentagon type, spiral going on there. Right? So I didn't specify. So, if you want to have fun with something, you can have fun with something. All right. Let's see what else we have here. Draw the result of a turtle program below. You can draw a dot to represent a stamp. Okay. So what we're going to do over here is that, I can just simply load this into the program and run it. And I'm sure like everybody did that, right? To check their answer. But what you have to do is you have to act like the turtle. So what you do is that basically over here you would say, okay, here's Bob. And generally what I'll do is if you get a problem where I'm having you do something, I'll follow something like this, you'll have like something like Bob.pen up 4 row in range 5, 4 dot in range row plus 1. So here what we would do is that we would say, so what is row? Row is 0. What is 0 plus 1? It's 1. So we'd put a dot, so we'd say Bob put a stamp down and move forward 50. Then we tell him to turn right, so that now he's pointing down. Move forward 50. Turn right again, so now he's facing back the way he came. And then we tell him to move forward equal to the number of dots he just printed. And then we tell Bob to turn around. And then he just does it again. And what that does is that he basically just makes a nice triangular matrix. So let's go ahead and doop. Right, and then there was something else. Well, I think I forgot to indent. Did I forget to indent something? Oh, yes. Forgot to indent these suckers, too. Indentation matters. All right, so there you go. Now, when writing this, I accidentally did something. I was like, oh, what happens if I do this, I believe. That was fun. But then I think, so that was fun, but that wasn't what I came up with. I think I came up with this. And this was, and it just gets big, and it just gets bigger and bigger. Now I came up with something where basically what it was doing, and I can't for the life of me remember it now. But basically, what it was going on was that it kept overwriting its old dots. It would basically go forward, and then it would go forward to back. It would go backwards to. Aha. There we go. So, okay. So good luck on your exam.
Can I get a demo lab 4 for you?
Sorry?
Can I get a demo lab 4?
Yeah. All right. Yeah, I'll be around for a couple more minutes until the pre-calc professor kicks me out.